The Advanced Encryption Standard, or AES, is one of the most widely used symmetric encryption algorithms used today. It's very likely if you're viewing this content, the data sent to your web browser was sent and encrypted using AES in conjunction with other algorithms, but we'll get into that later. It replaces older standards, and so far it's been used for a long time, and no significant weaknesses have been found in the algorithm itself. A few minor attacks, but it's robust. It's used everywhere. Even quantum computing attacks, theoretical quantum computers built like in the future won't be able to break this encryption. They can weaken it, but they can't really break it. So we're probably going to be using this algorithm for a while. So I'm going to skip some of the history. We'll get into the hands-on portion. We're going to use a tool called the GNU Privacy Guard. It's a tool that's common on a lot of Linux systems used for encrypting data. The GNU Privacy Guard can do public key, private key encryption, also known as asymmetric encryption, but it can also be used for symmetric encryption. We're going to be using the symmetric encryption option today. So let's take a look at our virtual machine. I'm in my Ubuntu virtual machine here, and I'm just going to make sure that I'm in my home directory, cd space tilde, print my working directory. I'm home. So that's good. So let's make a directory just to keep all of our files nice and organized. So I'll make dir crypto for cryptography, not for cryptocurrency. Then I'll cd into crypto using my tab completion. Even though it's only a couple characters long, hey, if I can avoid a few typos, fantastic. I'm going to create a new file called secrets. That's the file I'm going to encrypt eventually. I'm going to touch secrets.txt. Doesn't really matter what the file extension is, but it's just text, so I might as well give it a .txt extension. I'm going to edit this file, and you can put whatever secret message you want in this file. I'm going to nano secrets.txt. It's empty right now. That's totally fine. I'm just going to start typing. It was raining today. All right. Fun message. Control O to write it out, to save it. Enter. Control X to exit nano. And I'm back here. So now I can cat secrets.txt. I've got my message. Okay, so my file's all ready to go. So if I run ls l, I could do ls-al if I want to. Doesn't matter. I see I got my permissions here. I can see it's 22 bytes long. I can see I just made it. And I've got the name of my file there. So I've got some content in there. Just want to take a look at how big it is, because when we encrypt it, the encrypted size might change because we have to embed some other information in there. So your file, depending on how much text, your file will be different. All right, here's where we're actually going to do the encryption. GPG, that's the GNU Privacy Guard. -- output. What's the name of the file that we want to create? We will call it encrypted-secret.gpg. You could name it whatever you wanted to. The GPG extension is just a hint to ourselves to let us know that, yeah, this is an encrypted file. We're going to tell it use a -- symmetric algorithm. And we're not going to say use AES, but if we don't say anything, if we don't tell the GNU Privacy Guard what encryption algorithm to use for symmetric encryption, it's going to use AES under the covers. Just trust me. Then we have to tell it, okay, what are we actually going to encrypt? We're going to encrypt secrets.t. Did I make a typo? That line continuation, I wasn't sure if I accidentally hit the space bar. Secret.txt. This is the whole command. I'm going to hit enter. I called it secrets plural.txt. So I did have a typo in there. Goodness gracious. So I'm going to change it, add secrets.txt to that command. So I just hit the up arrow key, use my arrows to go back and add that S in there. No worries, everything's good. Hit enter. And it's going to say enter a passphrase. All right, what do I want for this passphrase? I'm going to call it password. Yeah, that's not good, but hit enter. Warning, you've entered an insecure passphrase. I know. Take it anyway. Just do it. Re-enter it. Wants to make sure I didn't make a typo, and I appreciate this. Password. We would want to create a more secure password if we were actually encrypting something that was important, but hey, there we go. That's the encryption key. So AES is the algorithm, and that passphrase that I put in there is the key. So anybody with that key could decrypt this file. Now, if you ran GPG and it's like, I don't know what you're talking about, there is no GPG on this system, you would have to install it. But on my Ubuntu server version, it came with the GNU Privacy Guard already installed, so I didn't have to do that there. So if you get an error, just like I did, double check that you type the name of that secrets.txt text file there. Why did I put that in there? Because I'm the kind of person who does that kind of thing, makes typos. All right. Our prompt looked a little bit different. If you were using Linux with a graphical user interface, you might get a box that pops up with, not in your terminal. Totally fine. We got the text version of this same prompt, so no big deal. We weren't even prompted to save this in a password manager, so don't worry about that. Let's take a look at what's in this directory. Now I've got two files in here. I've got encrypted secrets.gpg, and it's a little bit bigger. Why? Because it had to store some extra information about the encryption. This file grew quite a bit. This AES, though, doesn't really inflate your files all that much. Just because I started with so few characters in this file, it seems like it's about 5 times bigger now. But if you're encrypting a movie, it's not going to make your movie 5 times as big. This is pretty efficient. So don't be so concerned about the factor of growth here. We just added, 81 bytes to that file. Not that much. All right, so let's take a look at our files again. I'll cat secrets.txt. The text is still there. That file was not modified. But if I cat encrypted secret.gpg, my terminal is going to try to show me what's in there, but it's a bunch of binary data. It's not text characters anymore. Instead, it's a bunch of what would look like random zeros and ones. My terminal is doing its best to try to display that as text, but it really can't do it very well. I'm just going to hit enter again to get onto a clean line, so I'm not starting off with all of that stuff. So that's good. Now, we're doing both ends of the encryption and decryption. At this point, I would probably send my file to somebody so that they can decrypt it. We're going to sort of simulate that by deleting our secrets.txt file. So I'm going to rm to remove secrets.txt. Now if I list my files, I only have my encrypted file here. Occasionally on some systems, Linux will remember the fact that you just entered a password, and so when you decrypt it, it won't prompt you for a password because it just you just entered it, like you authenticated, all that's good. So we can run this command in practice. If you're actually using GPG to get work done, you're probably not going to run this command very frequently, but we're going to do it just to kind of clear out any passwords in memory. So I'm going to run gpg-connect. I'm going to hit tab. It'll fill that in for me. Reload agent/by. You don't have to remember that syntax. Hit enter, says okay. Okay, boomer. There we go. So if I ls again, still I've just got that encrypted file. So let's decrypt it. So this is our spy friend on another computer, theoretically. Our spy friend would run GPG decrypt, and I'm going to type E, then hit tab so it fills in that file name for me. There's only one file here that begins with the letter E, so it's going to complete the whole file name for me. What's the passphrase? So if I type ASDF, it's like, no, that's not correct. I'm going to hit the up arrow key, try to decrypt it again. What's it? Password, enter. It was raining today. All right, so I got my message out. It didn't create a file though, so I ran ls and it didn't recreate that file for me. I can ask it to create that file for me. So I can say gpg output clear.txt. You can name it whatever you want in theory. Decrypt. I'm going to hit E, then tab. It'll fill that in for me. I didn't have to re-enter that passphrase because it remembered, like, hey, you know what the passphrase is. If I'd reloaded the agent again, it would have prompted me. Now if I ls, I've got clear.txt there. So if I cat clear.txt, I've got the contents. So we could have encrypted a movie, an image, whatever kind of data we were encrypted using this AES algorithm and the GNU privacy guard. So key idea here, this AES algorithm, it's much more computationally intense than the Caesar cipher or the one-time pad, which are also both symmetric algorithms. The key idea with symmetric algorithms is that the same key is used to encrypt and decrypt your data. So if somebody captured my file in transit or got into my computer and copied this file, put it on another computer, as long as they know what passphrase was used to encrypt this data, they can decrypt it. Not really a problem, it's just something we need to be aware of. So that's a little bit how to use this algorithm using the GNU privacy guard.